Well, hello again. Today we are going to talk about classifying triangles, lesson 62. Now we're going to do just a little bit of reviewing. As we always do, there seems like there's some things we bring from before when we're talking about any math subject. It's very spiral. It goes from one thing to another and you keep going over and over and over things. But it's not a bad thing to go over things more than once. You have angles. What kind of angles do we have? Well, we have acute angles. They're really cute, little tiny angles. And they're less than 90 degrees. Here is an example. Please put that into your notes so you have an example of an acute angle. And this is the correct way to write the measure of angle ABC is less than 90 degrees. The little m here means measure, and B, that B right there that's in the center, is the vertex. Okay, so you should always be aware of the vertex of that angle must be in the center of your label. Okay? Then you have right angles. Right angles measure exactly 90 degrees. Not more, not less, not 91, not 89, but 90. Here is an example of a 90-degree angle. Here is how you would write. The measure of angle DEF is 90 degrees. Please put this in your notes. The other type of angle that we are familiar with and that we use quite a bit is called the obtuse angle. And obtuse is really obtuse. It's big, it's round, it's a very large angle. An obtuse angle is greater than 90 degrees. Okay? Typically, an obtuse angle is greater than 90 degrees and less than 180. Because 180 degrees is a different kind of angle. Okay? Be sure you have an example of this drawn in your notes, and here is how you would say the measure of angle RST is greater than 90. Now, likewise, we have acute, right, and obtuse triangles. Now, one thing you have to remember, all triangles have 180 degrees. And I've proved that before by taking a rectangle and cutting it in half. And we've talked about that the rectangle has 4 right angles. And because it has 4 right angles, it has 360 degrees. And if you cut it in half diagonally and make a triangle, 2 triangles out of it, then each of those triangles is going to have half of that, which is 180. So that's the proof. Now, we can label triangles by their angles. That means the angles that are inside the triangles. An acute triangle will have all the angles in the triangle measuring less than 90 degrees. A right triangle will have one angle in the triangle that is 90 degrees, and the other 2 angles that are in that triangle will be less than 90 degrees. They have to be, because the 2 plus the 90 have to add up to 180. And in this case, if all 3 of them are less than 90, then they will work out to be 180 as well. The obtuse triangle, which is, I drew an example of each type, but the obtuse triangle is harder sometimes for people to imagine. One angle must be obtuse, which means greater than 90 and less than 180. And your obtuse angle in this particular triangle is right here. Okay, that's the obtuse. And the other 2 angles, as you can see over here, this little angle guy right here, and this little one right here, they are definitely less than 90, so they are very acute, very tiny. Okay, I'm sure you have those in your notes. Now, there's some other information about triangles that we probably need to put in our notes, just kind of so that we know it. The side opposite of the largest angle in a triangle will be its longest side, which kind of makes sense if you look at it. Okay, take this one up, this one we had up here. Remember that obtuse one? Okay. I redrew it down here. Notice this is a humongous angle, which means that if you can think of these as legs, okay, and if you were doing like the splits and you split your legs that far apart, the distance between them would be really, really far, a lot farther than the distance of each of your legs. So this side here would end up being the longest side. So the longest side is going to be opposite the largest angle. And that works vice versa as well, because the angle that's opposite the longest side is going to be the largest angle. So it's back and forth. Largest side, largest angle. Largest angle, largest side. They're just across, they're always across from each other. Good stuff to put in your notes. Make sure that you draw the pictures. I will be looking for the pictures, and I will be looking for all this stuff written in your notes. You've got to have it in there. I'm sorry, it's too important at this point. Okay, a little more information about triangles. A little more information about triangles. The side opposite the smallest angle is going to be the, shortest side. So if you look at this example, and you can draw it into your notes, you've got a tiny little angle here. And so again, if you're sitting on the floor and you're trying to do the splits, but you just can't quite get the splits done, you can only open your legs just a little bit and you just can't quite get it, you can't quite get the splits done. Okay, little tiny distance between your feet. So smallest angle, shortest side. Again, opposite the shortest side would be the smallest angle. So shortest side here, smallest angle there. So it's pretty easy to remember. Across from the largest side will be the largest angle. Across from the shortest side will be the smallest angle, and vice versa. Okay, this is a little exercise. Using an angle measure provided, list the sides shortest to longest. Now you have to use the information given to help you. Okay, so we have 62 degrees, 74 degrees, and 44 degrees. Since this is the littlest angle, then the side opposite of it is going to be the shortest side. So you're going to write ST. Now, what's the next largest angle? Yep, right here. So, across from this next largest angle is this side. And so, the next longest side is going to be side RS. And of course, the very largest angle in here is this one right here. And so, across from it will be the longest side, and the longest side is RT. Not really that hard to figure out, is it? I don't think it is. Definitely this is going to need to be in your notes. Okay? So, a question. Which two sides of this triangle have the same measure? Well, think about it for just a second. Remember, we kept saying the side across from there. Okay. Obviously, this one's 108. It's clear across. This one across from here. This is the longest side. Okay. So, triangles have 180 degrees. If the sides have to be equal, if two sides have to be equal, that means that this side, this angle, and this angle is going to have to be 36 degrees. And if you take 108 plus 36 plus 36, 6 and 6 is 12, plus 8 is 20, 3 and 3 is 6, 7, 8. So all added up, they are 180 degrees. So this one's 108, this one's 36, this is 36. So that means that this side across from this 36 degrees is congruent to this side across from that 36 degrees. So this one and this one are exactly the same because the angles are the same. So JK and HJ are congruent because the angles across from them are congruent, meaning equal. Okay? Very important that you're able to explain that. Fact. Fact. A triangle with two sides that are equal and two equal angles is called isosceles. Now, I think you probably knew that, okay? This is the definition right here for an isosceles triangle. This up here, this one we just worked on, this triangle here is isosceles because this side and this side are equal. This is also isosceles, and the only reason I know it's isosceles is because I have these congruency marks. I don't even have to know the angles. As long as I have congruency marks, I know that it is equal. And they show here, or I show you, that RQ and PQ, or QR and QP, are equal. They're congruent. Here's your challenge question for today. What do we know if all three angles in a triangle are equal in length? Okay. We know that that triangle has what angles? That triangle is called what kind of triangle? What do we know? This is a challenge question. Okay, I have one more challenge. I think you can handle this. Okay, the triangle below has three angles with different angle measures. Therefore, we would have three sides with different lengths. What do we label this triangle? What kind of triangle is it? It's not isosceles, I can tell you that. Okay, and it's not the same as the challenge that we just went over with the sides that were exactly the same length. It has a special name. It has a special name. Now that we know that special name, that's important. The other thing I want you to do is I want you to categorize the lengths of the sides simply from the angles, which we did earlier in my explanation. So, I will put this up here. This is what you need to do for me. You need to show me, give me the name of this triangle, and you need to label the sides. And remember that you also have a challenge here, that you have to tell me about a triangle that has three equal sides and why. You must do this. You must do both of these challenges. It's required. It's not optional. Thanks. I will talk to you later. Have a great day.